let's take a look at these problems. These are mostly calculator exercises, but if I recall correct from yesterday, there were a couple of you that had some calculators that worked a little differently than the rest. We'll try to go over the main types here again today, but some of them we probably won't be able to show you. For 1 through 6, we're just finding the value of the function. The sine of 39, we just hit sine, sine 39. Somebody's got their microphone on. If you want to make sure your microphone is muted. Hit enter, we get 0.6293. Now I should double check my mode, and I am correct there. So 0.6293 is my correct sine. Tangent of 18. The tangent of 18 degrees, and just to be good for good form, we should close that parentheses. Now we get 0.3249. And cosine of 75, giving us 0.2588. Now, just some things we had mentioned yesterday. Sine and cosine will always be between -1 and +1. Tangent could be anything from -infinity to +infinity. This just happens to come out to be 0.3249 here. Cosecant, cotangent, and secant are the functions where we have to use those alternative buttons on our calculator, and we have to use that reciprocal key. For most of us, that reciprocal key was like this, x -1, or it might be 1 over x or 1 over box, something like that. Cosecant, remember that works with the sine. So the cosecant of 12 degrees, we do sine of 12 degrees, and then we do close the parentheses first and then hit that reciprocal key. Giving us 4.8097, so 4.810. That is the cosecant of 12 degrees. Cotangent works with tangent. The cotangent of 59, we do tangent of 59. Again, we close the parentheses and then we use the reciprocal key. We get 0.6009. And for secant of 21, we use the cosine. Goes with secant. And again, we close the parentheses and put the reciprocal outside. 1.071. And once again, similar to the sine and cosine, since the cosecant and secant work off of the sine and cosine, the secant and cosecant are always either less than -1 or greater than +1. Just the opposite of sine and cosine. And of course, the cotangent, just like the tangent, can be any value from -infinity to positive. Over here now, we're going the opposite direction. We know the value of the function. We want to get back to finding the angle. If we're told the cosine of our angle is 0.7383, to get back to the angle, it's an inverse cosine. So most of us, that's the second button, second cosine. And then we just type in the 0.7383. It gives us 42.41 degrees. For angles, we typically only go to 2 decimal places for the angles. For sine of b equals 0.2256, we do the inverse sine of 0.2256. Gives us that angle B is 13.04 degrees. Tangent equals 1.884. We'll do inverse tangent of 1.884. Giving us that angle is 62.04 degrees. Secant. Now remember, the secant goes with the cosine, so we're going to do an inverse cosine. But since we are going backwards, the reciprocal goes inside the parentheses. So we put in the 2.032, then we hit the reciprocal key, before we close the parentheses, giving us an angle of 60.52 degrees. For cotangent, that works with the tangent. So it's going to be the inverse tangent of 0.9223. Again, since we are finding the angle, the reciprocal goes inside the parentheses. So we hit the x negative 1, then we close the parentheses. We're at 47.31 degrees. And for cosecant, that cosecant goes with the sine, so it's an inverse sine, 1.884. And again, the reciprocal goes inside the parentheses. It's 32.06 degrees. That was just our generic calculator work of, if you're given the angle, find the given function of that angle. Or if you're given the value of the function, go back to finding the angle. The next step was to use a triangle. So if I have a triangle and I call this side or angles A, B, and C, the sides are labeled with small letters rather than capital letters, and they're labeled by the angle that's their opposite. So this over here is opposite angle A, so it's called side little a. So this down here would be side little b because it's opposite angle B. And of course the hypotenuse is across from angle C, and that's called side little c. If I ask you to find the sine of angle A, remember sine is the opposite side over the hypotenuse. Well, the hypotenuse here is always going to be C. But if I'm looking at angle A here, the opposite side is side A. B would be the adjacent side. So what I want here is the opposite side, A, over C. Well, let's throw some lengths in there to make this a little more user-friendly. I'm going to tell you that side A is, what do I want to throw in there? We'll go 12 inches. E is 35 inches, and C is 37 inches. I believe that'll work out. So anyway, that would mean that sine of A is opposite of 12 over the hypotenuse of 37. We'll divide that out. 12 divided by 37 is 0.3243. That's the value of the sine of angle A. Even though we don't know the angle, we don't know the degrees, we could find the sine by using the ratio of the sides in that right triangle. I asked for the cosine of angle A. Well, cosine is adjacent leg over the hypotenuse. Here the adjacent leg is the 35 over the hypotenuse of 37. 35 divided by 37 is 0.9459. One thing I should point out is I did not put the units on any of these numbers. Could have put inches in there. But both of those numbers, in order to compare them, they have to be the same units. Both of those are inches. And so the inches would just cancel out anyway. So any ratio, remember, is unitless because both numbers have the same unit. The units cancel out. So I just have to make sure that when I put those numbers in here, that both of them are the same units. Since everything in this triangle is measured in inches, that's already taken care of. Tangent of angle A, well, the definition of tangent is the opposite side over the adjacent side. So that would be the 12 over the 35. Or 0.3429. Before we go on to some of the off functions here, the less common functions, I want to go back and I want to find the sine of angle B. Sine is still opposite over hypotenuse. But for angle B, I'm looking at angle B here, the opposite side is now the 35 inches, and the adjacent side is now the 12 inches. So the opposite side would be 35 over the hypotenuse of 37. That gives us 0.9459. Now, just like we mentioned yesterday, the sine of B and the cosine of A are the same. Well, that's because since this is 90 degrees here for angle C, and we know a triangle adds up to 180 degrees, the other two angles have to add up to 90. They have to be complements. And remember, cosine is really defined to be the sine of the complement. So since A and B are complements, the sine of one is equal to the cosine of the other. So if I do the cosine of angle B, which would be the adjacent side over the hypotenuse, well, for angle B, the adjacent side is 12. The hypotenuse, of course, is still 37. That is 0.3243. You will notice that that was equivalent to the sine of A. So again, A and B are complements. The sine of one equals the cosine of the other. Tangent B opposite over adjacent is going to be 35 over 12. So 2.83, I believe. 35 divided by 12. Actually, it's 2.9167. 2.917, we'll put it at. Those are just our standard functions. Now, our off functions, like secant. Secant of A, remember, secant is just hypotenuse over adjacent. It's the reciprocal of the cosine. So it's going to be 37 over the adjacent side for angle A is the 35. That would be the adjacent. So 37 over 35 gives us 1.057. The cosecant of angle A. Come on. Cosecant, remember, is hypotenuse over opposite, or the reciprocal of the sine. Hypotenuse is 37 over the opposite side of 12. That's going to be 3.083. And, of course, we could have the cotangent of A. Cotangent is adjacent over opposite. That's going to be the 35. 12. Otherwise known as 2.917. You might notice those two are the same. A and B are complements. So the tangent of one equals the cotangent of the other. Well, we've looked at some relationships here. I want to formalize them. If I give you A plus B equals 90 degrees. Of course, that's telling us that those are complements. Almost 10 o'clock. Time for my morning spam calls come through. Sorry. So A plus B equals 90 degrees. So they're complementary angles. If I tell you that the sine of angle A equals 0.4 and the cosine of angle A is I gotta change that a little bit. We'll make this 0.8 and 0.6. That'll work out better. That way I know they work. The sine of angle A is 0.8. The cosine of angle A is 0.6. Ask you to find sine of angle B. Well, because they are complements, the sine of angle B is going to equal the cosine of angle A. That's going to be just 0.6. Likewise, if I ask you to find the cosine of angle B, well, again, since they are complements, the cosine of one equals the sine of the other. So the cosine of B equals the sine of A, are just 0.8. So that is our basic complementary identity. The sine of one equals the cosine of the other. But then we also have that identity that the secant of A is equal to 1 over the cosine of A. So if I ask you to find the secant of angle A, that would be 1 over the cosine of angle A, or 1 over 0.6, which is 1.667. Likewise, the cosecant of angle A. Cosecant of an angle is the reciprocal of the sine of that angle. So cosecant of A is 1 over the sine of A, which is 1 over 0.8, or 1.25. Similarly, I can find secant of angle B. Secant of B is 1 over the cosine of B. We found the cosine of B to be 0.8. That's 1.25. The cosecant of B would be the 1 over sine of B. And we know the sine of B is 0.6, so 1 over 0.6 is 1.667. Again, it makes sense. Cosecant of B should equal the secant of A. Since A and B are complements, the cosecant of one should equal the secant of the other. And of course, the secant of B also equals the cosecant of A as well. They're both 1.25. Let's talk about the tangent a little bit. Tangent of an angle is equal to the opposite side over the adjacent side. Now, we looked at this very briefly, but we know the sine of an angle is the opposite side over the hypotenuse. And the cosine of an angle is equal to the adjacent side over the hypotenuse. So if I combine those two functions, sine divided by cosine, what do I get? Actually, I probably shouldn't have put it there. Let me put it down here. Well, the sine is opposite divided by hypotenuse. Cosine is the adjacent divided by the hypotenuse. Well, if I do that as proper division here, I have opposite over hypotenuse divided by adjacent over hypotenuse, dividing my fractions. Well, to divide fractions, keep the first fraction the same, and I do the reciprocal of the second fraction. So I'll make that hypotenuse over adjacent. And you can see that the hypotenuse cancels out. It cross cancels. So what I actually have here is opposite over adjacent, which is my definition of tangent. So the tangent of an angle can be found by doing the sine of the angle divided by the cosine of that angle. So if I ask you to find tangent of angle A, that is the sine of A divided by the cosine of A. Well, the sine of A was given to be 0.8. Cosine was 0.6. That's 1.333. That is the tangent of angle A. If I ask you to find the cotangent of angle A, well, there's two ways I could look at it. I know that the cotangent of A equals the tangent of B because they're complements. Tangent of B equals sine of B over the cosine of A. So sine of B was 0.6, and cosine of B, oops, this should be cosine of B here. Sine of B was 0.6, and the cosine of B was 0.8. That's a 0.75. So I can find the tangent and cotangent of those angles. So if I know the sine and cosine of the angle, I can find secant, cosecant, and tangent of those angles. And if I know a relationship, like here, in this case, A and B add up to 90 degrees, so in other words, they're complementary, I can use it to find all those other functions as well. So if I give you that sine of angle A equals, oh, I got to find a decent one here. Let's say sine of angle A equals 0.866. And tangent of angle A equals 1.732. Find, let's start off with the cosine of angle A. Well, the cosine of angle A, I'm going to take a little extra work here. We know that the tangent of A is equal to the sine of A over the cosine of A. So I can fill in some numbers there. I know the tangent is 1.732. That has to equal the sine of 0.866 over the cosine of A. I'm trying to find the cosine of A. Now to solve this, I'm going to just make this a proportion. So I put the 1.732, I put that over 1 so that I have two fractions or two ratios equal to each other. And I will cross, multiply, and divide. 1 times 0.866 divided by 1.732 gives us 0.5. So the cosine of A is 0.5. Once I have that, all of my other trig functions fall into place. I can find the secant of A because it's 1 over the cosine of A. So it's 1 over 0.5, otherwise known as 2. I can find the cosecant of A because it's just 1 over the sine of A, otherwise known as 1 over 0.866, which I believe is 1.15. Let me double check that. It is 1.155. Is the cosecant. And I can find the cotangent of A. Cotangent of A is just 1 over the tangent of A, the reciprocal of the tangent. That's 1 over 1.732. And I believe that is 0.577. It is 0.577. So from two of the trig functions, I can find the other trig functions just by knowing those relationships. Now there's one other relationship we want to look at here. In my unit circle, if we had our angle right here, that's our angle theta. This distance right here, if I bring that sign down, is the sine of that angle. This distance, we said, was the cosine of that angle. Well, that forms a right triangle where the legs are the cosine and the sine. And of course, the hypotenuse here is the radius of the circle. That always has a value of 1 because it's a unit circle. So if I take this, the sine of theta squared plus the cosine of theta squared, that's just a squared plus b squared equals c squared, equals 1 squared. Well, 1 squared is just 1. So this is the sine of an angle squared plus the cosine of an angle squared has to add up to 1. So this helps us go even further. If I just tell you that the sine of angle A is 0.25, I can find the cosine of A because of this identity. So 0.25 squared plus the cosine of A squared has to add up to 1. So 0.25 squared is 0.0625 plus the cosine of A squared equals 1. We will subtract the 0.0625. To get the cosine of A squared is 0.9375. To find the cosine of A now, I have to square root both sides. The cosine of A is equal to the square root 0.9375. Give me 0.9682. The cosine of A. So by knowing that the sine of A was 0.25, I could find the cosine. And remember, we saw up above, once we have the sine and the cosine, we can find any of the other angles by doing those ratios for tangent and secant and cosecant. So if I have a triangle again here, let's say I know side A is 11 feet, side B is 60 feet, and side C is 61 feet. I ask you to find the sine of angle A. Well, remember, sine is opposite over hypotenuse. Of course, the hypotenuse here is side C, the 61 feet. But if I am looking at angle A, the opposite side is the 11. The 60 here would be the adjacent side. So opposite over hypotenuse would be 11 over 61. If I divide that out, 11 divided by 61, I get the sine of angle A is 0.1803. So I now know that the sine of angle A is equal to 0.1803. So I can find the angle A now. Angle A is the inverse sine of 0.1803. So on the calculator, I'll do second sine. Rather than punching that number back in, I'm just going to do second answer. Telling my calculator to use that previous answer so that I don't have to write it down and type it in, which rounds it off. Gives me that's 10.39 degrees. So this angle here is 10.39 degrees. If I want to find the tangent of angle B, for angle B here, the opposite side would be the 60, and the 11 would be the adjacent side. The tangent is opposite over adjacent. So here that would be the 60 over 11. Which if I divide that out, gives me, was that 0.55 or 5.55555, I believe. It is true, 5.45. So 5.4545. So that, again, that's telling me that B, or tangent of B, equals 5.4545. So that B can be found as the inverse tangent of 5.4545. Or, let's do a second tangent. Let me do this. Previous answer. And I get 79.61 degrees. So I can use those sides to find the missing angles by just picking a trig function. Here I just decided to use sine. I had all three sides, so it didn't matter. I could pick any trig function I wanted to use to find those angles. And once I get the value of the trig function, I can do the inverse to find the missing angles. Notice 10.39 and 79.61 do add up to 90 degrees. So that when we add our right angle, we are at our total of 180 for the triangle. Well, in that triangle, we knew all three sides, so we could pick whatever trig function we wanted. That might not always be the case. For this triangle here, I'm going to give you that we have, oh, let's say that we have 15 inches for side A and 123 inches for side C. Is that right? No, it should be 113 inches for side C, sorry. Now, if I want to find, of course, I could find side B here by simply doing a squared plus b squared equals c squared. A squared would be the 15 squared plus, well, b squared, b is what we're trying to find, equals c squared of 113 squared. So I could just do, I'm just going to shorten this, rearrange my formula. B is equal to the square root of 113 squared minus 15 squared. Giving us, oh, what did I get there? Missed a number. 113 squared minus 15 squared. Oh, give us 112. So I find B is 112 inches. But again, like I mentioned, I'd like to go back to original information, the information we were given, because even though I'm pretty confident in that 112 inches, I calculated it. And every calculation we do, there's a chance for an error. So it's always safest to use the given information when we're working on a problem. The engineering thought on that is just what I said, is if I calculate it, there's a chance there was a mistake. And so every calculation is a chance for the mistake. So I put as few calculations into the process as I can, and I do that by going back to the given information. The other thought process there is, if these numbers are wrong, they were given to me by somebody else, so that would be somebody else's fault, not mine. Sounds a little shallow, but that's one of the thought processes in engineering. So anyway, if I want to find angle, come on. If I want to find angle A, Here's angle A. I look at the sides that I have. 15 would be the opposite side. 113 would be the hypotenuse. Opposite hypotenuse means I'm going to be using the sine. The sine of an angle is opposite over hypotenuse. I am looking for the angle A. The sine of A equals, the opposite is 15 inches over the hypotenuse of 113. Notice I dropped the inches, as I said, because those units have to be the same, so they're going to cancel out. But I should double check, make sure both of them were in the same unit, and both of them were in inches. So I'm going to do the inverse sine, second sine, and I just do the 15 divided by 13 right in the parentheses. I don't have to calculate it out first. That gives me, oh, what's going on now? 15 divided by 113. I keep missing that one, extra one there. Gives me 7.63 degrees. Angle A up here is 7.63 degrees. Now I know already now, just by subtraction, that B would be 92.37 degrees. But I would be using that 7.63 degrees, which I just calculated. And remember, we like to go back to the given information whenever possible. So to find B, I have the adjacent side and the hypotenuse. It's going to be a cosine. Cosine of theta equals adjacent over hypotenuse. So it's the cosine of angle B. The adjacent is 15 over the hypotenuse of 113. So I am going to do an inverse cosine of 15 divided by 113. And it does give me 82.37 degrees. This angle here is 82.37 degrees. So I can find missing angles in that triangle by just looking at the information I'm given, the sides I'm given in relation to that angle, and determining what trig function it represents. I can go the other direction. If I am given one angle, let's say I'm told that this is 32 degrees, and let's go with side C being given here. Let's say I'm told that side C, the hypotenuse, is 40 feet. Now, of course, I can find angle B here. That is going to be 58 degrees, simply subtracting from 180 with the 90 and the 32. Or realistically, I just take 90 minus the 32. Those two angles have to be complements. But now to find side A, I'm going to use the angle I'm given. I'm going to use angle A. So according to angle A, side A would be the opposite side. So I need a trig function with opposite side in it. And I look at what I'm given. I'm given the 40, which is the hypotenuse. Opposite and hypotenuse are sine. Sine of an angle equals the opposite side divided by the hypotenuse. So my angle is 32 degrees. I know my angle, so I can put it in there. The opposite side is A. That's what I'm looking for. And my hypotenuse is the 40 feet. Now to solve this, what I do is I go back to when we did our original definition of these trig functions, it was sine over 1. So I'm going to put that back in. This is sine of 32 degrees over 1 equals A over 40. So now it's a proportion again. And to solve it, all I have to do is cross multiply and divide. Sine of 32 times 40 divided by 1. Now when I punch this in, sine of 32, be very, very careful. Make sure you close the parentheses on that so that your calculator knows you're done calculating the sine and you're multiplying now by something else. You're going to times 40 and divide by 1. Now, of course, we know that dividing by 1 isn't necessary, but we're going to do it just for form. This comes out to be 21.20 for A. So A is 21.20 feet. This was in feet, so A has to be in feet. To find B, Again, using angle A, B is the adjacent side. So it's going to be a cosine I'm using. Cosine of an angle is the adjacent side over the hypotenuse. Well, here I have that the angle is 32 degrees again. The adjacent side is B, and my hypotenuse is 40 feet. So once again, I'll put this over 1 so I can cross, multiply, and divide. So it is the cosine of 32. Again, it's very important that I close that parentheses after the angle, after the cosine, times 40 feet. And again, I don't have to put in the divided by 1 if I really don't want to. Usually B is 33.92. So this here is 33.92 feet. So I could find those missing sides from the angle and the trig function. Now we might have something like this. Where I might tell you that angle B here is 67 degrees. And that side B up here is 18 centimeters. Now again, side A over here is really easy to find. I just subtract from 90, I get 23 degrees for side A. Or for angle A, I should say. For side A, I have angle B. I'm going to use the given information, which is angle B, 67 degrees. A would be the adjacent side. I am given side B, which is the opposite side. Well, opposite and adjacent are tangent. Tangent of an angle is opposite over adjacent. You've probably noticed that I write down that definition to start off each problem, and I highly recommend it. That way I write out the definition out of my notes, so I've got the definition correct, and then all I have to do is fill in the information. The angle I'm using here is the 67 degrees. The opposite side is the 18 centimeters. The adjacent side is side A. That's what I'm trying to find here. Well, right now, that would be very difficult to solve as it is. But when I put in that 1 to make it a proportion, it becomes pretty simple. It's 1 times 18, which is just 18, divided by the tangent of 67 degrees, giving us that A is 7.64. A here is 7.64 units long. In this case, it would be centimeters. Then we could find side C the same way. We could do A squared plus B squared equals C squared, but that would require me to use information that I calculated. And remember, we try to avoid that. We try to avoid using information we calculated ourselves. So if I'm looking for side C, that's my hypotenuse, and I'm still being given the opposite side. So opposite and hypotenuse make up the sine. Sine of an angle is the opposite side of the hypotenuse. So this is sine of 67 degrees equals, the opposite side is 18 centimeters over my hypotenuse of C. This over 1, so I can cross, multiply, and divide. 1 times 18 is 18, divided by the sine of 67 degrees, giving me 19.55 degrees. Or not 19.55 degrees, 19.55 centimeters, I should say. Two things that you need to double check here. One is the hypotenuse should be the longest side, and it is. The hypotenuse should always be the longest side of a right triangle. Next is our two legs, A plus B, has to add up to be greater than side C. 7.64 plus 18, that is 25.64. That is bigger than 19.55, so that's true. So just a couple of things you can do to double check yourself. We will work on that more on Thursday. For right now, I think you guys have had enough. There is a quiz out there that I want you to work on. That quiz has 20 questions. So usually I plan about 30 minutes for that quiz. In fact, I just did get it posted, so it is posted out there. There's 20 questions on it. So like I said, I usually plan like 30 to 35 minutes for that. So that's going to be most of your second hour here. And then the rest will be time to work on your homework here. Again, out of the big book. It'll be page 854 through 856. Exercise 34-1, the odds. And page 857 through 8. No, it's just 857. There's no through. And that'll be exercise 34-2. Again, the odds there. I'll be on the network here for a few minutes if you have any questions. Otherwise, good luck on your quiz, and have a great day.